In this video, we're going to be talking about how to solve a system that is a set of equations that has two equations with two unknowns, x and y. I'm going to be giving you three different examples because there's three different things that could happen. And in particular, I'm going to show you the method of elimination. There is another method called substitution, but we'll save that for another video. So let's start with this one. First things first, there's two equations. I'll call this equation A1 and this equation A2, because this one will be the set of equations B and the set of equations C. So for this, I think, all right, for elimination, I want to eliminate, get rid of, either the x variable or the y variable. I can do either one, and as long as I do all the correct algebra, it actually doesn't really matter which one you choose to get rid of. However, one may be easier than the other or require less steps. So if I look in this case, if I wanted to get rid of the x's, I notice that in order to make these numbers the same so that I can subtract them and get rid of them, I would have to multiply equation A1 by 5 to make this a 10. And I would have to multiply equation A2 by 2 to make this a 10. So that's two multiplications I'd have to do. Whereas if I look at the y's, I've got 3y and 9y. All I would have to do is multiply equation A1 by 3 to make it a 9y, just like equation A2. So that's what I'm going to do. I'm going to multiply equation A1 by 3. So that's going to be 3 times 2x plus 3y equals 6. Remember, you have to multiply the other side as well. And so when I do this, I get 6x plus 9y equals 18. And that's from me multiplying each one of these by 3. So if I now write down equation A2 again, my 5x plus 9y equals 14, what I'll do is subtract the second equation from the first. And when I do this, 6 minus 5 is a 1x. 9 minus 9 is just 0, so I have eliminated the y's. They're gone. And 18 minus 14 is 4. And in this case, I figured out what x is. X equals 4. In general, you may have a number here still on the x, and you'd have to divide that over to get x all by itself. But in this case, x equals 4. I'm not quite done because I know what x is, but I still need to figure out what y is. To do that, I'll take my x and I'll plug it into either one of the equations. It doesn't matter which one. Because I used A1 to multiply by and change it, I'll pick A2. But that's not actually a math reason, that's just an intuition reason. So looking at equation A2, I have 5 times 4, because that's what x is, plus 9y equals 14. And I'm going to figure out what my y needs to be. So this gives me 20 plus 9y equals 14. Subtract the 20 over. 14 minus 20 gives me a negative 6. 9y equals negative 6. I now divide both sides by 9. And this gives me y is equal to negative 6 over 9, which I can simplify. Divide top and bottom by 3, and I get negative 2/3. So this first set of equations, set A, has x equals 4 and y equals negative 2/3 as the solution. What this means visually is that I've got some line here. I'm not claiming that this is exactly what the lines look like, but let's say I just have two lines. And I ask the question, where do they intersect? Well, I found their intersection point. They intersect when x equals 4 and y equals negative 2/3 at that point there, wherever that may be located. So that's how I go about and I solve a system of equations. And assuming I've done all my math correctly and I get that point, that would be my answer. However, I have these other two examples because things can happen. For example, if I look at this one here, and I call this equation B1 and equation B2, let's do the exact same process, try to eliminate a variable. Once again, I've got the 3, 9 situation going on here. So to make the x's match, I'll multiply equation 1 by 3. Now when I do that, 3 times equation B1, so it's 3 times 3x plus 7y is equal to 1. And when I multiply that in, I get 9x plus 3 times 7 is 21y. And then 3 times 1 is 3. Then I write down the second equation of 9x plus 21y equals 6. and I subtract this second equation, notice that I've eliminated the x's because 9x minus 9x is just 0. I didn't write down 0 over here. I could. Here I'm writing it down explicitly because that's 0. And then 21y minus 21y, that's also 0. And then 3 minus 6 is negative 3. So notice I have no variables here. And all I get is 0 equals negative 3. I didn't do any mistakes in my algebra. I just got a statement that 0 equals negative 3, which, if you look at that, that's clearly not true. 0 does not equal negative 3. That's just false. And yet I didn't do anything incorrect. So what's going on? What this means, if you've done all the steps correctly and this happens, you get just a false statement. What it means is you've got this line here, and you've got this line here. And you're asking, where do they intersect? Nowhere. These lines are parallel, meaning they have the same slopes, and there is nowhere where they cross. They do not intersect. So if you then try to use elimination to show where they intersect, you're just going to get a blatantly false statement. Doesn't mean you did anything wrong. It means that there is no solution. These lines never cross. So it's important to realize that, because often students will get stuck because they'll do all the work, they'll get something like this, and they can't figure out what they did wrong. And the reason they can't figure out what they did wrong is they didn't do anything wrong. This system has no solution. Okay, let's look at this last example here. Call these equations C1 and C2. Same process. I'll think, all right, I want to get rid of one of the variables. I look at the x, and I notice, ooh, if I multiply this by 2, this will also be 20, and I can subtract. So that's exactly what I'm going to do. 2 times equation C1, 2 times 10x plus 5y is equal to 15. Multiply that in, so I get 20x plus 10y is equal to 30. And then when I write down the second equation, 20x plus 10y is equal to 30. Something very similar is happening here. I subtract, the x's cancel, the y's cancel, but now over here, 30 minus 30 is 0. And so once again, I have no variables, they're just gone. But this isn't a false statement. Notice in the previous set, we got 0 equals negative 3. That's just wrong. That's not true. It's never true. But 0 equals 0? Yeah, that's true. It's so true, we'd say it's trivially true. It's kind of obvious, like, yeah, 0 equals 0. What does this mean? It means you're asking where do the lines intersect? Well, here's line 1. Here's line 2. So when you ask where do they intersect, everywhere, because they're the same line, which once I multiplied it by 2, you can look at it and you can see, yeah, it's pretty obvious that they're the same line. So these ones are technically they're parallel, but they're so parallel they're on top of each other, the same line. So we'd say there's an infinite number of solutions. And of course you could write infinite this way. Infinite number of solutions. Meaning if you pick just any random x and y and you plug them in there, they'll work. You'll get the same number in each equation. So that's how, by elimination, you would solve systems of linear equations, the case where there's one solution, the case where there's no solution, and the case where there is an infinite number of solutions. And that was this example.